Good morning, my name is Paul Baker from Glasgow Caledonian University, and here we are in the School of the Built and Natural Environments research laboratories. I'm standing in front of our environmental chamber facility. We've used this facility for carrying out research on behalf of Historic Scotland into improving the energy efficiency of traditional windows using fairly simple methods. The chamber is divided into two halves. On this side, we can control between 10 degrees and 40 degrees Celsius and also vary the humidity. On the other side, we can control down from 10 degrees to minus 20 degrees, but typically we'll use test conditions of 20 to 22 degrees on the warm side and 2 to 5 degrees on the cold side of the chamber. The sample is mounted between the two chambers, usually in an insulated surround, and we then instrument the sample up using heat flow meters and temperature sensors. Here we are at the warm end of the chamber, and this is one of the control panels. We can simply control the set points from this front panel, and we can control the temperature and also the humidity. Normally, for the type of tests we do, we keep a steady temperature, but it's also possible to program these so that you can have a temperature or a humidity cycle, for example, similar to a nighttime setback in a building, or on the cold side to look at the temperature swings that you would experience during a day. And it's also possible to program the chambers from a PC. But for most of the test work that we do, it's quite simple to use the control panel here. This is the temperature controller. So we have the actual temperature measured in the chamber, and in green here the set point. So we can control the set point quite simply by pressing the button here. Here we are at the cold end. The cold chamber has additional features. We have the facility to spray water onto the test sample, and also to use a bank of infrared lights to simulate drying from solar radiation. Here we are at the control panel, and we have the controllers for the infrared lamps. We have the facility here to key in a set point for the lamps, and we can measure a temperature on the surface of the wall, and using the lamps control the surface temperature of the wall at that set point. Here are the control units for the IR lights. It's actually usual to program these from the PC so that you can control more easily the duration that the lamps are on for, and also the set point used. Here we have the humidity controller. At the moment we're operating the chamber below 10 degrees, so there is actually no control on the humidity. And here we have the the temperature controller, which is operating at the moment at 5 degrees for this particular test. This is an example of an insulated surround that we use to mount the test windows in between the two chambers. It's also useful in that we have this normally lined with plywood, although now it's foam insulation. And we can use the plywood, for example, for mounting secondary glazing systems in front of the window. Okay, so this is a typical example of the type of window that we've been testing, both for Historic Scotland in the lab and also carrying out in situ measurements for change works at Launceston Place in Edinburgh. This is the type of heat flux sensor that we use typically for these kind of tests, both in the lab and in situ, both on glazing and on wall constructions. So for windows, we back the sensor with double-sided tape, thoroughly clean the surface of the glass, and then stick the sensor onto the window, usually in the middle of the pane. Once the heat flux meter is applied to the window, we then add temperature sensors. We use type T thermocouples, which we apply both to the surface of the heat flow meter and also to the surface of the glazing, both inside and out, quite close to the heat flow meter. So we use a transparent tape. It's also important to try to remove as much of the air as possible to have good contact with the glass. Okay, this is one of the typical loggers that we use, particularly for in situ use in buildings. So it has a relatively small number of channels, but it's quite flexible in terms of the type of input that we can use. So we can add both heat flux sensors, which give a voltage output, and also temperature sensors.